versus mass. What exactly is the difference? Weight is the force in newtons put onto a surface because of the planet's gravity and the object's mass. So weight is a force. Mass, however, is the amount of matter dense into an object in kilograms. So mass is how much stuff there is in something. But what does that mean? Let's say you wanted to find your mass. Well, all you need to do is get a scale that displays your mass in kilograms. It's really that simple. Although it should be mentioned that some scales show your weight and not your mass. Most digital scales these days already calculate your mass for you, so you don't have to divide the mass displayed on your scale by gravity again. But what about your weight? Since this is physics, we have a formula for this. Weight equals mass times gravity. Assuming you're on Earth, you would take your mass, say 57 kilograms, and times it by Earth's gravity, 9.807 meters per second squared. Your result would be your weight in newtons. 558.1 newtons is our example's answer. So how would you find your weight on other planets? Well, that's fairly simple. Just take your mass and times it by the planet's gravity. For example, you wanted to see your weight on Jupiter. You would take your mass and times it by Jupiter's gravity, 57 kgs times 24.79 meters per second squared, would equal 1,413.03 newtons. Now for weightlessness. Weightlessness is when you have no forces being pushed up on you. You can actually be weightless right now just by simply jumping. When you reach the top of that jump, or the climax of that jump, you will actually be weightless because you're no longer going up and gravity is no longer pulling you down. Now you're probably wondering, is the weightlessness on the International Space Station the same weightlessness? Well, it feels the same, but it's executed differently, because the International Space Station is actually moving around the Earth faster than it falls towards the Earth. So this is why the International Space Station has a stable orbit around the Earth, because it is moving faster than it is falling. Gravity. What is it? Why do we have it? What is it? What does it do? Gravity is the attraction from large masses to other smaller masses. Everything has gravity, but since Earth's gravity is so large, we simply cannot feel the gravity from other things. So, in theory, if you were to sit close enough to someone, the two of you will end up being attracted to each other by each other's gravity. But you would have to be sitting so close that you'd pretty much be touching already. So that's why we don't float off into outer space, because the Earth is constantly pulling on us and attracting us to it because it has such a large mass. Gravity is constantly trying to pull us to the center of the Earth. But the reason we do not go to the center of the Earth is because we have many layers of rock, stone, dirt between us and the center of the Earth. That is why gravity fails to pull us to the center of the Earth, but succeeds at keeping us on the surface of the Earth, thus not letting us fly into outer space. And now for some maths. Maths, I know it's not fun, but we gotta do it for a little bit. So we're gonna use the formula EP equals mgh, or energy potential equals mass times gravity times height. Now, what is energy potential? Well, it's the potential energy of something dropped from a height. Let's say our prop had a mass of 10 kilograms and we dropped it on Earth from 10 meters. It would have an energy potential of 908.7 newtons.